Okay, just a very quick abstract what I'll be talking about. We tend to think in terms of models, but a model alone won't beat neoclassical economics. We need an entirely new paradigm. Partly that is showing up an alternative to what they're obsessed about, which is having what they call microfoundations for building their models, and a toolbox for extending it, and puzzles which new researchers can work on before we have a full paradigm. We need foundations, this is obvious in this audience, but foundations that conform to the laws of thermodynamics. Most economists wouldn't even know that there are such laws. And I'll be showing my Minsky software as one toolbox that could be used to bring system dynamics to economics, mainly because of a special feature it has I call godly tables. And then I was going to spend a lot of my time bashing the absolute garbage that has passed for neoclassical climate change economics, which really emphasises the need not just to reform economics, and part of that would be abolishing the nonsense called the Nobel Prize there, but breaking away from their dominance of economic policy in general. I think they're really the main threat to capitalism is neoclassical economics. Now, to talk firstly about why one reason economists have been so resistant to system dynamics is they believe they've got to have what they call good foundations, which nobody can object to having good foundations. But what they see as good foundations is deriving everything from microeconomics. Now, their micro alone is nonsense. So I go through that in debunking economics. But this is the typical attitude. This is a very vociferous defender of the neoclassical orthodoxy, actually speaking to a United States Congress meeting about the failure of economics to foresee the crisis. And his opinion, if you're going to have an interesting model, it must be a dynamic, stochastic, general, equilibrium model. That's all they think you can actually have as a decent foundation. And even after those models completely fail to see the crisis coming, even someone who's been relatively flexible for a neoclassical economist in admitting there are problems, Olivier Blanchard, starts saying, well, you've got to start from micro foundations. Where else can you start from? Now, I want to show very simply that you can derive macroeconomics directly from macroeconomics itself. Again, I'm talking to the converted here in some ways. You are aware of complex systems and the fact that you can't derive a higher level from a lower level, but economists don't understand that yet. So I want to show you can actually start from definitions that they cannot deny. The definitions are true because they're definitions. You can then convert those into dynamic statements. You can make that into a simple system dynamics model using extremely simple behavioural relations, far less complicated than the guff they go on about in their courses in microeconomics, but still something which is at the core of what they believe. It's like a Taylor series expansion of a complicated expression. I'm simply starting from the first linear term. And add more definitions to make the model more complicated and more realistic later on. So you can't dispute when you start with indisputable definitions, and that's what I want to do. So I'm going to start from a definition of the employment to population ratio, the wages to GDP ratio, the private debt to output ratio, the output to labour ratio, and the capital to output ratio. And in terms, I use lambda for the ratio of how many people have a job to total population, omega for the wage bill divided by GDP, D for private debt divided by GDP, Y being the usual simple economists use for GDP. The output to labour ratio, I use the symbol A for that, and the capital to output ratio, I use the symbol V. So you start from those definitions and differentiate those three. And what you get is three statements that are true by definition. The first is the employment rate will rise if economic growth exceeds the sum of change in the output to labour ratio, this one, and population growth. The wages share of output will rise if wages grow faster than GDP. That's fairly obvious straight from the definition. And equally obvious, the debt ratio will rise if debt grows faster than GDP. Now, putting that into equations where I use x hat to give the 1 over x dx dt, that's the term for the definition of the rate of change of the employment rate, the definition for the rate of change of the wages share, and the definition for the rate of change of the debt ratio. Now you convert it to a model with extremely simple rules. So I've got the definitions all here. So I have a constant rate of change in the labour to output to labour ratio, constant rate of population growth, use a pointer there, pardon me. Capital output ratio, rate of change of your capital being investment minus depreciation, the wages share, a simple linear Phillips curve, equally simple linear investment function saying investment as a fraction of GDP is dependent is a linear function. That's the slope of the linear function. That's the 0 point of the linear function of the rate of profit. Change in debt finances investment. If investment exceeds profits, your debt rises. If investment are less than profit, your debt falls. Profit being net of wages and interest payments, and then I've got initial conditions. So it's all very simple stuff. Now, when I put that into a Minsky model, this is the sort of behaviour I'll get. I'll just go across to showing that in Minsky itself. Pardon me having a few extra windows open here. No, that's not the one I wanted to show. Pardon me. It's this one. So that's exactly that same model. I'll just shut this window down. So these are flowchart definitions of exactly the same term. This is the different integral sign here. So the integral of the rate of change of the the employment ratio is the employment ratio, and that's saying it's the employment ratio times the growth rate minus the sum of labour productivity, as that rate of change is often known, and population growth. Now, if I simulate this model, I get a cyclical system. And one thing you'll notice about those cycles is they're first of all diminishing, so it looks like you're heading towards an equilibrium. What you actually get is apparent convergence to an equilibrium and then divergence. You get a diminishing level of cycles and then rising cycles over time. Now that's an incredibly simple model, but what I'm getting out of that is behaviour that in a very stylised way paraphrases what happened back in 2008 with the financial crisis. So when you solve this model symbolically, you find there are two equilibria, two meaningful. One with a positive wages share, a positive employment rate, and a positive but finite debt ratio, but a bad one with zero wages share, zero employment, and an infinite debt ratio. And when you do the technical analysis of this model, you find that the good equilibrium has one negative real eigenvalue, that's what causes the convergence, but two complex eigenvalues with zero real part, which was what gives you the cycles there, for a level of the, that's supposed to be lambda s there rather than lambda z, pardon me, for a low slope of the wage change function, and you get a positive real part for above that level. That's why you get that apparent convergence and then divergence. The negative eigenvalue pulling you in, the positive component of the complex eigenvalues pushing you out as you get close to the equilibrium. And that is fundamentally what's known as the Pomo-Manaville route to chaos, which was found back in its studies of the Lorenz model, one of the transitions to instability in the Lorenz model. So let's actually make my screen a bit larger. I can see you there, Cal. It's good to see at least one face while I'm talking. Okay. So what I've got is the simplest possible model you can build. Three definitions, two behavioural functions, all linear, all constant parameters, and I get something which paraphrases what happened during the so-called Great Recession. You had a period of diminishing cycles before the crisis, which they called the Great Moderation. Then you had the crisis, which they called the Great Recession. You had rising inequality, and in my model there's a rising share going to bankers, which comes at the expense of the share going to workers. And when I look at the empirical data, I find the same sort of cyclical behaviour. I find a role for the level of debt, which is left out of neoclassical models completely. That's the cyclical nature of corporate debt. That's the Ponzi scheme of the level of private household debt, which rose dramatically to finance the dot-com bubble, and then its crash afterwards. Here you have a collapse in the employment rate, and then a recovery. But the cyclical behaviour that I've shown in an extreme version of that model is turning up in the data as well. So that is a model which took a tiny amount of time to build in terms of writing it from first principles. Any decent first-year calculus student could do it in about 10 minutes. But it gives you the core behaviour of the economy, which completely escaped the neoclassical model. And in fact, what are anomalies in the neoclassical model end up being core predictions of this new paradigm. So I can expand the model again from what I've got as a real model there with no price dynamics. I can include nominal in the model just by saying I'm now working in terms of nominal wages and nominal GDP and nominal debt and nominal GDP as well. And I then get three statements which again are true by definition, but they now include inflation in the second two. So the wages share of output will rise if money wage demands exceed the sum of inflation plus the growth in labour productivity. And that's simply a factual statement. It's actually the dynamic version of a definition. And the private debt ratio inflation will also reduce the rate of growth of private debt. So I think that those expressions, and I can generalise on to a more significant model, I can include government spending, multi-sectoral production, etc., etc. So what you're getting is by looking at the structure of the economy, you generate a dynamic model of its behaviour, its system dynamics. And that is far more fruitful than the way neoclassicals stumble through an incredibly complicated and boring derivation of difference equations from microeconomic first principles, which themselves are wrong. So what I'm showing with this sort of modelling is that it's the system that determines the behaviour, not this idea of micro determining macro. And it's far from equilibrium, it's complex and it's non-linear. So that's one part of my attempt to reform economics to make it something resembling a science rather than a mythology, which it is right now. Now, the major flaw from a thermodynamic point of view in economics, and not just the mainstream, it's also non-orthodox schools like the post-Keynesian, is they've always modelled output when they do mathematical models of production of the economy. They've modelled output as a function of labour and capital input with no role for energy. So this is the so-called Cobb-Douglas production function. This itself is a piece of nonsense. With the usual parameter values, it's simply a non-linear mapping of output equals wages plus profits to a model of production. So it's not really a model of production at all, but that's what they do. There's no role for energy in that. This is what the post-Keynesians do. This is actually much more empirically accurate. You largely find that output is a linear function of the level of capital stock as measured and defined, but neither have a role for energy. Now, what I realized about 4 years ago, this has been obvious for 40 years to me, you can't have production without energy. It violates both the first and second laws of thermodynamics, okay? And if you, as Eddington said so beautifully so many years ago, if your theory is against the second law of thermodynamics, there is nothing for it but to collapse in deepest humiliation. Well, economists have been glorying in deepest humiliation for 50 or 60 years. It's about time they stopped. Economists, even though they dominate the debate over climate change, they have nothing fundamental to say about what causes it, which is the role of energy in production. So can we make economics consistent with the laws of thermodynamics? And I realised, actually, in Bob Ayres' house, I imagine a few of you know Bob Ayres, the person who's been really one of the leaders in trying to develop an energy-aware approach to economics. I was staying at Bob's house. It's full of statues, as it happens. This is in Paris before he moved out 1 or 2 years ago. And walking back from going to the bathroom one night, looking at these statues, this thought popped into my head: labour without energy is a corpse. Capital without energy is a sculpture. And within 10 minutes I had a basic piece of logic to say that labour and capital can be treated as means to convert energy into useful work. So you make energy as an argument to labour and capital rather than tacking labour on as a third factor, which is what economists have done before. So I'm using E capital lambda and E capital K for the energy input to workers and machines respectively, and then I replace labour at time t and K at time t with labour with the energy input at time t and capital with the energy input at time t. And the simplest way to define those, quite straightforward, is to say that labour, the energy at time t, is the number of workers times the energy consumption per worker times the efficiency with which that's turned into useful work, and exactly the same idea for capital. So there's the number of workers, energy consumption per worker, which in America is thousands of kilowatts, tens of kilowatts per day, and the efficiency of conversion of that into useful work. The same thing for machinery, number of machines, energy consumption per machine, efficiency of conversion into useful work. And of course this term, the product of these two has remained pretty constant a Roman slave probably put as many calories into work as an unskilled labourer does today, probably more for that matter. What's been rising over time is this term, the energy throughput of the average machine per year, which has risen from if we go back to the days of the James Watt steam engine, that consumed about 10 tonnes of coal per day. The Falcon 9 rocket consumes about 9 tonnes of kerosene per second. So we've got a 25,000, 30,000 factor increase in the energy throughput of the average machine, the representative machine, whatever, and that's really been the source of growth over time. So what I've done using that is to develop an energy-based and a matter-based model of production. I won't go into those here, but I have those available on my Patreon website for anybody who wants to check them out. So what you finally get is a thermodynamically valid foundation for modelling production, and of course you can also, once you have production, you have waste, carbon dioxide being related to energy consumption, resource depletion, and so on. So this, to me, is my attempt to build a decent foundation for an integrated approach of economics and ecology. But the primary objective in building Minsky, the software package I showed you a moment ago, was to make it possible to model financial flows. And I'll show Minsky in a moment, but it's the unique features. I'm sure there are plenty of users of BenSim, maybe some Simulink users here, people who are aware of system dynamics in general. Why did I design Minsky? Because it added, the thing I added was the capacity to model financial flows using double entry bookkeeping, and that's what I call godly tables. But since I was designing a software package from the ground up, I thought I might as well have some fun. So I brought in some ideas I learned from my days of being a computer software editor for a Australian computing magazine, and that is things like directly entering the maths onto the canvas rather than having to use a palette. So I'll just actually show you that quickly, pardon me. I'll bring up, I have two programs actually, one I call Ravel, which I'm happy to chat about later. It's still in development. It's built on top of Minsky. But just to show what I'm talking about there, so if I want to type a multiply sign, for example, I just press the multiply key or the divide key. I could even type an integral very rapidly on screen. If I want a variable like, for example, lambda, then I just type it into a window here, and I've now got lambda, as you can see there. There's also formatting, so if I, for example, if I type, say, omega underscore t superscript k, not that that means anything, what I get, as you can see, is superscripts and subscripts. So that's all quite straightforward in Minsky. It's something you can't do in any other system dynamics program. We overload operators, so for example, if I have a plus key here, then I can add this, and I can add that, and I can add that all to the one mathematical input, and just do the equation here, call this Fred, drag this in here, and then the equation, now including Fred, has those three elements added together. So just to save clutter in terms of designing a model. Latex formatting, as I've showed you a minute ago, latex output equations as well. It passes value by name as well as wire. So once I've defined something here to be Fred, I can take a copy of it and put it somewhere else and feed it elsewhere into the system. This is a dreadful equation coming out here. But I can do all that stuff easily, and I'll show you sliders operating in a moment. It has weak grouping. Has an alternative to that. You can bookmark different regions on a 100,000 by 100,000 divine canvas, so that works pretty well as an alternative. And we're bringing in multidimensional data importing, parameter fitting, and direct entry of equations on additional tabs. So that's all being done so far. So just to show you the model I demonstrated a moment ago in a more conventional system dynamics program approach, this is investment minus depreciation, gives you the capital stock, divided by capital output gives you the output level, divided by the labour productivity, as it's called, gives you the number of workers. That divided by population gives the employment rate. That feeds into a wage change function here. Multiplied by the wage rate gives you the wage. Multiplied by labour, you get the wage bill. Subtract that from output and also subtract interest. You get profit. Divide profit by the level of capital, you get the rate of profit. Feed that into investment function, you get gross investment. If gross investment exceeds profit, you get the rate of change of debt, and you pay interest on debt. Okay? So that's reading the model in a more conventional system dynamics framework. As you can see, the same result as the model I showed a moment ago. But the real strength is double entry bookkeeping. And I'll just quickly just give a very fast demo of that. I won't try to finish a model here. I'll just have a new system. Okay. But the new element that Minsky adds that other programs don't have is this thing we call a godly table. And that is what a godly table looks like. It uses assets, liabilities, and equity to define variables. So if I, for example, say type reserves here, and then loans, and then firms as one deposit account in a bank, workers as another class of deposit accounts, and then bank. And if I then say, for example, I have lending money is a loan, say loan to the firm sector goes in the asset column, and that means you put money in the firm sector's account. You repay, then that's going to be minus, I'll make that minus RF to save a bit of space here, and that reduces the level of debt. And then if you pay wages, then that's going to be wage coming out of here and going to the workers. And then if I have the workers consume, then I'll say there's money coming out of the workers account for consumption and going to the firm's account, and then consumption by the bankers. That's going to be money coming out of the bankers account and going to the firm's account. And I forgot to put the interest in the, so there's, if you charge interest, then the firm has to pay interest from here, and it goes over to the equity. And what you can see is the program is checking to make sure all the entries sum to zero. Once I've done that, I've got a simple model of a banking sector, and if I want to then see it from the point of view of another sector in the economy, I can open up another godly table and say what liabilities haven't yet been made assets for somebody. Well, that's the firm's bank account. So Minsky brings those operations across. What assets haven't been shown liabilities? Well, there's loans. Minsky's now fixing those two up, and I can now say, well, this is going to increase the equity of the firm sector. I'll just call this firms underscore equity. So that's CB, that's consumption by workers, that adds to equity, that subtracts, and so does paying wages. And I'm now building quite a sophisticated model, well, simple but sophisticated model of the financial flows involved in a economy model. And if I realise, well, actually, I should have really included shareholders inside there, then I can just actually just whack shareholder here, and then I can have pay dividends, which is going to go from the firm sector to the shareholder sector, etc., etc. So it's very simple. I'm not sure what I've done there. I've created some sort of bug. Maybe the word div is causing a problem, I'm not sure. Anyway, that's rapidly designing a model that would take a lot longer to do in the standard flowchart software. So that's the main reason that I use Minsky. And then you can simulate a model like that. So I'm just doing it here, for example. I've got a simulation where I'm showing that if you increase the rate of lending, there's an increased flow of credit, you get an increased incomes. When you have repayment happening more rapidly, you have a decline, negative credit. That's what caused the financial crisis in 2008. And the fact that I knew that is why I could see this coming. So I can simulate the model using a slider. I'm using Greek subscripts there, as you'll see. Overloaded operators. That's showing off some of the features of Minsky. Now, you can also use it not just for financial modelling, but also for things like compartmentalised systems, like, for example, the SIR models that are now being used to model the coronavirus. So the simplest model is basically a modified predator-prey model, and it's saying the proportion of people who are susceptible is a negative function of the number, the proportion that are infected times the proportion of susceptible people in the overall population. Now, if you make the standard assumption of these models, because pandemics occur much faster than standard births and deaths occur, you assume a constant population. So you can just divide through by n. And then you've got this expression for the rate of change of the number who are susceptible but not yet infected. There's then a recovery rate for those who get infected, and then you've got to make sure everything is stock flow consistent. So those terms have to be the same, and those terms have to be the same. Now you can do that in a program like MATLAB, etc., but the Godley table is actually ideal for doing that. So I just defined 4 populations: population, susceptible, infected, recovered, and 2 flows, infected and recover. And that's the overall model. So let's actually see if I can find that one amongst the many I've got open here. So that's the model, and I can then simulate the model and see it happening in real time. I'll let this run a little bit so you start to see the decline in those who are susceptible but not infected. Usual story, nothing happens, then all hell breaks loose. Okay, have I done something wrong here? Oh no! Okay, I'm not sure why I haven't. What have I not? The recovery. I had the periods wrong on that model. It's finally, okay, we're finally seeing a bit of a change there. That's if we had a slow recovery rate. I'll increase the recovery rate and see what happens. The time to recovery. And let's say the infection speeds up as well for the heck of it. And then let's say the infection rate slows down again. So again, you could do that in Simulink or MATLAB or Stellar or anything else. It's just showing that it makes it the fact you've got this table here that lets you can make sure the stock flow consistency is maintained, makes setting up the model and defining it much, much easier, and extending it is also quite straightforward. So those are the equations generated by the model. I add a new compartment, for example, of the fact that you have the exposure before you get infected with the coronavirus. It's easy just to add that as an extra column, which I've done over here. And then I add exposure as another element to it, and then I have deaths as well. It's very simple to extend this model and keep the structure right. All you then have to do is define the flows themselves, which is done with the definitions like this over here. I might just see if I can actually... Okay, so that's the definition of exposure. And then Minsky converts that into a set of equations over here. Okay, so I'd be really delighted if people here would download Minsky, check out the beta build in particular. It's free, obviously, because it's open source. And we're releasing a beta pretty much once every month now, courtesy of a grant from the Friends Provident Foundation of £200,000, which more than doubles the amount of money that's been spent on Minsky so far. So I want to know what you think of it. Certainly find any bugs for us. And most importantly, what features does it not have that you'd have to see before you'd move across from using something like BenSim or Simulink and so on. Now, that's the positive stuff. Now it's time to trash the mainstream. And it's not hard because they've supplied the garbage themselves, and they awarded a Nobel Prize to the person who did most of that garbage. This is a set of quotes from one book, and I want to compare it to a set of quotes for another. So that's saying, I'm going to move your image around here, Cal, in a second. So, 2 degrees will stress human societies and destroy many natural ecosystems. 3 will impair the stability of human civilization. 4, a probable full-scale global collapse. 5, most of the globe will be uninhabitable, and any humans that are left will be having a precarious existence in small refuges. 6, potentially a runaway process which will render the biosphere extinct, and potentially it could destroy the capacity of life on the planet. That's rather extreme. But what's the alternative? Well, the alternative view is that in global annual losses for a 2-degree increase in temperature will be between 0.2 and 2% of income, and that's a comparison of GDP whenever we reach 2 degrees, which might be, by the way things are going, next week, but it's more likely in one decade or so. GDP then will be 0.2 to 2% less than it would be in the complete absence of global warming. In other words, the growth rate would be affected by of the order of 0.0102% rounding error in terms of normal calculations of GDP. 3% maybe reduce the growth rate from 1 point of per capita income from 1.5 to 1.485% per year. Again, a trivial decrease in the growth rate. And a 6-degree increase would reduce GDP by 7.9%. Now, am I talking about the same planet? Well, unfortunately I am. The quotes on the left-hand side are from Mark Linus in Our Final Warming. The quotes in the right column, the first one comes from the IPCC. Okay? Economists are now quoting the IPCC saying how trivial climate change is going to be for the economy. Lead author, Richard Toll. His name's going to come up a few times. The second was from Nordhaus's 1991 paper, Expert Opinion on Climate Change. And the third is Nordhaus's most significant paper after he was given the Nobel Prize, 2018. Now, how did Linus reach his conclusions? By pretty careful compilation of research by paleontologists into what the climate was like over the last 250 million years, and looking at particular periods where the temperature was 1, 2, 3, 4, 5 and 6 degrees warmer than today, and then collating all of those to say what are the implications of each of those for the temperature we are proposing on the climate by global warming. The conclusions of the economists: first of all, a textbook economics belief that markets can cope with almost anything. So if we increase the temperature to the level of Venus, let's work out what the GDP will be. They confuse temperature today with raising overall global temperature. In effect, they're confusing the weather with the climate. And I'm not joking. They literally assume that anything done indoors will be immune from climate change. They distort or ignore the scientific literature and its outright distortions, which and in any other situation would be the grounds for a lawsuit. And they minimise every step of the way the implications of climate change. So I want to go through some of these points. So the first one, how economists' beliefs are driving what they say is going to happen, not their models. The models don't even come into it. It's their beliefs about the nature of capitalism. So in 1991, Nordhaus did a survey of 19 experts, and the inverted commas are necessary. And he had 3 natural scientists who are profoundly concerned about global warming and the impact it'll have on the economy. At the other extreme, 8 respondents whose specialisation in economics is not environmental economics. Now, they're not experts, but they're people that he surveyed. And he said when you compare the predictions of the economists to the predictions of the scientists are predicting something 30 times worse than the economists argue. This is all in the paper. He was quite upfront about the huge gap between what economists believe and what scientists believe. So those are the predictions of economists of 2 scenarios. The A is 3 degrees increase by 2090. The C, I think, is 6 degrees by 2090. So economists made those trivial predictions. That's what the scientists, and it's only 2 of the 3 scientists, by the way. One refused to answer the question. Thought the question was so stupid. So that's the first thing. The experts they consult on the expected impact of climate change on the economy are economists, not people that know anything about climate science. So then this is how Nordhaus approached doing his work. Human societies thrive in a wide variety of climatic zones. Well, that's true. In the current planet, yes, we range everywhere from Antarctica to the equator. And he said non-climate variables swamp climatic considerations. This is comparing the climate today in one part of the globe with the climate of the day in the other part of the world. No wrong with that. But what's this got to do with global warming? Well, what they do is they say we can use this current data about GDP and temperature today to predict what's going to happen with climate change. They assume that they try to make it sound intelligent. They assume that the observed variation of economic activity of climate over space holds over time as well. Anybody who knows their math, that's the ergodic assumption, of course. But what they're mistaking the climate and GDP variations we say today when there's going to be no change. Of course, there is no change in the total energy in the biosphere. What's going to happen when you have an incredible increase, as we all know, in the amount of energy the atmosphere will retain because of increased CO2? So what they used was this sort of data: average temperature data for the USA per state and gross state product per capita data. And if you pull out that data, what you find is this sort of distribution. The bottom of this chart here, pardon me, Cal, I'm moving you around again. The bottom of this chart is the deviation of the temperature in the United States from the average, which is 11.5 degrees Celsius. And then this is the deviation of gross state product from average in percentage terms. I haven't got the average. There's about 35,000, I think. So that's the one state that happens to be smack dam in both averages. That's the overall distribution. And what you do, if you put a quadratic to that, you're going to find a weak relationship, okay? A correlation coefficient of 0.31. It's not, you don't throw it out straight away, but it hardly explains the data. So that's the relationship you get. And when you put it in an equation, it says that the percentage change in GDP for each change increasing in degrees Celsius is going to be minus 0.00318 times the temperature variation squared, which I think everybody knows how trivial that is. So that's a temperature deviation from the US average. That's the GDP variation from the US average. They then assume that climate change will have exactly the same effect. And here's that same statement from Toll again. Now that gives you a criminally small estimate of what's going to happen with climate change. I'm now juxtaposing actual forecasts from Nordhaus's model in 2011 to the parabola I've just derived a moment ago to what Linus had to say. So 2 degrees, he predicts a 1% fall in GDP. Okay. My little parabola, 1.3. 4 degrees, he says a 4% fall in GDP. My little parabola, 5%. 6 degrees, 8% fall in GDP. My little parabola gives 11%. This is the end of civilization, according to Linus, and I think obviously his views are correct. This is nonsense. This is garbage. But this is the sort of stuff they've been using, writing the IPCC reports. The only part of the IPCC report that politicians ever pay any attention to is the economic section. This has been swamping everything being done by scientists. Now, Toll got involved in a Twitter fight with me, which I was quite delighted he did because I could expose how stupid their ideas were by what he had to say in return. So here he's saying 10 Kelvin is less than the temperature difference between Alaska and Maryland. Climate is not a primary driver of income. That's that geographic assertion. And with this being exposed on Twitter, some people outside economics got involved. So Daniel Swain is a climate scientist, and he's saying the obvious. 10-degree increase in global temperature is not remotely the same as just adding 10 degrees temperature everywhere. And then along comes Toll defending his position. People thrive in very different climates. Climate determinism is what he's calling global warming. And then this smart aleck finish at the end here. If a relationship, you can probably see your face and his, Cal. If a relationship doesn't hold for climate over space, you cannot confidently assert that it holds over time. Well, let's put a steel rod through this piece of bullshit. Let's put it in context. Now, the amount of energy that is involved in raising the temperature of the atmosphere alone, as much as Toll is casually throwing around here 10 degrees Celsius, is equivalent to letting off 1.6 Hiroshima bombs per square kilometre over the surface of the planet. Well, that's not energy we're providing, that's the additional solar we have to retain to raise the temperature of the atmosphere by 10 degrees Celsius. And to do the same thing to the ocean, 250 times as much energy. This is the stuff they're completely ignoring in economics. So sorry, Cal, was that 30 minutes to go or 10 minutes to go? Oh, good. 40-minute warning, okay, I'm running close to time. So this is what they did. They took temperature in two places and compared them. And this is a statement, I'll go a bit more rapidly now. They say, by comparing one area with a warmer site, the cross-sectional can discern what would happen to that place if it warmed. They have no idea of what climate change actually means. It's a dramatic increase in the energy level of the universe. So what they've done, effectively, is assume that they ignore the fact that there are fundamentally three ways, or two major ways, you can vary the temperature on the planet. You can move where you are on the planet without changing global temperature, or you can increase global temperature. Now, what they've done is they've assumed that GDP is a quadratic function of temperature. So I've broken it down here and said, well, let's look at changing temperature by changing the global temperature versus changing the local temperature. What they've done is compare two places at the same time. Florida's 7 degrees warmer than the average for the states, Dakota's 10 degrees colder, and they then simply subtract one from the other. This, of course, cancels out. They get a value for coefficient for alpha 2, and they say, oh, let's assume alpha 1 equals alpha 2. That's fundamentally what they've done. And that is actually confirmed by one of the more recent papers that at least acknowledge that there is a relationship between temperature and GDP over time. Different story. Now what I'm looking at, they actually assume that only sectors that are actually exposed to the weather are going to be affected by climate change. So here's from Mendelssohn, the very first paper again done by Toll here. Activities done inside clean rooms or surgeries won't be affected by climate change. And he then estimates that 87% of American GDP will be unaffected. This is the table that he shows the components of GDP. And he then assumes manufacturing and mining, 26% of GDP, non-sea-based transportation and communication, finance, insurance and real estate, except for the stuff on the coast, commercial and wholesale trade, government services, even the rest of the world won't be affected by climate change. He leaves out 87% of GDP. Simply assumes it won't be affected by climate change. That's where those crazy numbers come from. And Toll was happy enough to say, oh, well, if the temperature of the planet increases by 10 degrees, we'll all move indoors with air conditioning. I mean, you couldn't make this stuff up as an insult, but this is what they do. Now, to make it worse, when they read climate scientists, this is Nordhaus referring to a paper by Lenton. Here he says, his damage function doesn't have sharp thresholds or tipping points, but that's consistent with the survey by Lenton. Well, I read the survey by Lenton, and what Lenton actually said is, society may be lulled into a false sense of security by smooth projections of climate change. We will trigger a number of tripping elements this century, completely contradicting what Nordhaus has to say. So throughout the whole, even in the model itself, which I haven't even bothered being into the model yet, the assumptions are bad enough, but in the model, the damages reduce GDP. They don't affect technology, the labour force, or the number of machines. It's awful, awful work. And yet it got given the Nobel Prize. And in the Nobel Prize lecture, he actually said that a 4-degree temperature increase is optimal because it minimises the cost both of climate change and climate change mitigation. Now, why did this garbage why did it even get published? It's because it's defending an inherent belief that neoclassicals have in the superiority of an unfettered free market. And because climate change requires controls on markets, therefore they assume it can't be a problem. They trivialise it all the way through. So we have a flawed model of capitalism, and they'll go through the flaws in debunking economics, but it's believed by its proponents because it explains everything to them. It's not mathematics, it's mathematics. It's not science, it's scientism. And when they say this is a simplifying assumption, manufacturing and services not being affected by climate change is a simplifying assumption. If it's wrong, your conclusions are wrong. They don't understand the role of assumptions at all. Now, how did this get past referees? Because they're always making mistakes like this. They're always defending their theory by making assumptions that are necessary for the theory to work. And they then ignore that the assumptions don't apply, neither does the model. And once you get published, you become the referee that decides what gets built up. That's what's happened here. Nordhaus and friends referee their own papers. So you get this sort of nonsense being put forward by von Lomberg. I'll get through to the punchline here of all these bits and pieces. Yes, nowhere near as serious because the IPC tells us so with high agreement. And who's one of the authors? Again, Richard Toll. So it's an existential threat to humanity. And what scientists are telling us is far more likely to apply. And we have to get rid of the economists to have any chance of surviving what's going to happen on the planet. So we can't expect economics to reform itself. It's time we invaded. And I certainly put a plea out to all the scientists and physicists, engineers and so on here, come in and take over economics from the economists.